Going live. Okay, now we're live.
Hello, hello. I guess I know by the time I start hearing us in the stream, and especially me, myself, and I. Oh yeah. Oh, there we go.
All right, I'm also gonna.
Oh, nice. The latency isn't even that high. That's pretty good.
Need
5
to.
people waiting.
Wow. Okay.
Sweet. Hello, hello. Is anyone watching yet?
Actually, something's not right with our. I
Setup.
see. What is this? Whoa.
Oh wow. I guess. Yeah, no, that wasn't me. That's you.
That's me. I don't know what happened here.
Do you need to like make the thing smaller or something like that? Could be that it's like.
Yeah,
Is that
it's
like the
ginormous. I don't know how that happened.
yeah, it's you can right click and say fit to screen or something, and then it at least is like totally visible, and then you can drag and drop it smaller. I think that's what I tried previously in OBS. Yes, we are experts at this.
Absolutely not. Where? You said right click on the
Right click on the video thing that you see, that you just dragged around, and then
This
it has
one.
like transform or something,
Transform, yeah. Okay.
and then fit to screen
Fit
or
to
something
screen.
like that. And then you can now you see the thing, and now it's easier to make smaller, right? Yeah, exactly. You got it. There we go. I think if you put it to the right and then make it slightly bigger, it should like snap into place or something. I'm not mistaken. But yeah,
It
something
snaps
along
onto
those
the
lines.
side, but not with the other.
Yeah.
Anyway, this is
good enough.
this is good enough.
So now I can put myself in the everything's fine background.
Oh no. I see. I need to actually
the thing again.
okay,
Yeah, make it a different window.
If I pull this out.
Yeah.
Can I still make this?
Yeah, that worked.
Oh no, now you're gone.
Yeah.
We totally know what we're
work.
doing.
This is going well. I mean, my background says all of it, right? It says it all. So it's perfect.
Anyway, how can I pop out chat with OBS again?
I guess we can make the slide an actual OBS scene where we have this in the background and then switch it over once we actually start. That would be ridiculous production-wise.
Yeah, that was the idea, but I definitely did not execute well.
We can try. There's an echo in the audio.
Oh, is there? Is
for
that
whom?
for Matthias or for me?
I mean, I feel like the audio is the least of our problems. I mean, now it is, but up until 5 seconds ago, it wasn't. From both.
Huh, interesting. Let me check my mic settings again. Yeah, no, that should be all good.
I don't hear an echo listening on the stream. I just hear like... Yeah, I think it's just your microphone is picking up background things, maybe.
That
So
could be. Unfortunately,
the
there's
background
some...
thing, you can just hear that you're in a room.
I see. Okay. So I need to. What we're saying is we need to order some like sound
No, I think the
panels.
filter option, like the noise compression or like the compressor, is probably what you need to tweak again a bit. But
All right.
is it in the is it enabled? Maybe you
Yeah.
want to check that.
Now compressor is enabled. It's
Okay.
exactly the same.
I mean, it's totally variable. Let us know, Jonas, if it's if it's bad that you would like not continue watching, then we'll fix it. But okay, I would say we just continue for now.
Yeah.
But yeah, if others have the same feeling and impression, then we can like go into Frederick's settings again and tweak it, I guess.
Yeah.
Right. I reserve this background for when we actually fail to do something.
Huh. That's weird.
It repeats half a second. Okay, I don't think that's. Can you check? Because like if I listen in on the stream myself, it just seems fine. Do you have like? Did you maybe come from Twitter and like it's still live streams in the other browser tab or something like that? Like, I think it's fine. Like listening in myself. Like there's no echo in the music either, for example. Okay, yeah, Thomas says it's all fine. Okay. How about others? Okay, audio is good for me. Mathaf says Mathaf. Oh god, I feel I butchered the name. Sorry about that. Okay, so something maybe Jonas, if you check your browser tabs, maybe you have us open twice or something. Maybe like Twitter sometimes does that.
Yeah.
Like if you came from Twitter, you can imagine that. Which brings me to I wanted to retweet. Anyway.
Huh. So Matthias has an echo.
It seems there was a Twitter tab open somewhere.
Okay.
Oh my god. It feels weird to be right about this one, like to be honest.
I mean, I do this
I guess
all the
it
time.
happened to yeah, exactly. It was just I don't know, but okay, glad we fixed that one.
Awesome.
Perfect. Always happy to help.
Alrighty. Maybe we'll get started at 15. How's everyone in chat? Finishing up your week, or what's your... Are you listening in the morning? Yeah. Yeah, it's even I'm so glad that like browsers invented the sign of having the speaker symbol in the tab. It gets even harder when you have multiple windows, right? At least, but at least you can see it on the tab.
Yeah, that was a genius move.
Yeah.
And like, it took me, I don't know how long to figure out you can actually click that icon to mute the tab. It's pretty sweet. You can just click on it and then it like mutes that tab, and then you can unmute it right from there without even going back to the like video playing in the tab and stuff.
Huh, I didn't even know that.
So subtle. Yeah, it's really cool.
Nice. Friday afternoon sounds good.
Evening in Dubai. Dubai sounds hot already. Like if Spain almost has like 30 degrees Celsius. We just hit like 10 Celsius in Berlin, and it was like sunny for once, like the last 2 days. But Dubai sounds like summer already.
Is it ever not summer?
That's a good question. I don't know. Maybe Jonas knows. I would guess he knows. So what's the weather like? 23 degrees Celsius or 74 Fahrenheit. Nice. That seems nice. Not too warm, not too cold. Nice. Doesn't matter the temperature if you can talk about profiling. What a transition. I guess one more minute and we get started talking about profiling.
Should be a fun one. Kubernetes is already pretty well optimized. I'm curious if we'll find something. Maybe this will be the first time that we're unsuccessful. I know that lots of companies have already put lots of work into this, so we shall see. Alrighty, I guess we can get started. So yeah, hey everyone. I think we've got a couple of people that are new in chat. Let us know what got you here, what brought you here. But yeah, today we're going to be looking at Kubernetes, and we'll attempt to find some performance optimizations in Kubernetes so that we can hopefully, Kubernetes is run a lot around the planet. So if we can shave off some CPU cycles of some Kubernetes components, that means that we're saving the world some CPU cycles. So, hopefully that would be beneficial to the planet, to electricity usage and so on. So that's the goal today. Like I said, Kubernetes is already pretty well optimized, so we will see if we can be successful at this. But yeah, we'll see. And let us know if you have any ideas in chat of what to look at, or if you see anything. We're definitely not perfect. If you spot anything, let us know in chat. But what we're gonna start with is we've got one of our production clusters at Kubernetes, and what we can do, for example, I think what would be interesting at first to look at is the kubelet, because not only do we have like the kubelet runs on actually every single node within Kubernetes clusters, right? So if we can shave off something from the kubelet, that would be really nice, because it's actually proportional to the number of nodes used in Kubernetes clusters worldwide. The control plane definitely could be interesting as well. We can, if we don't find anything in the kubelet, we could definitely look at the API server as well, or other components. Or, if we're completely unsuccessful, we can look at more ecosystem components, maybe like kube state metrics, or, various adapters or anything like that. But yeah, I think this is where we'll start. Unfortunately, I don't know why, but OBS always closes chat for me. So Matthias, if you can keep an eye on chat and let me know, that would be super helpful.
That's what I'm here for. Next to profiling, I guess.
So yeah, what we're seeing here is the Polar Signals cloud product. In essence, it's identical to the Parka open source project, except that this is fully managed for you and horizontally scalable. You don't need to worry about anything. You can just send us as much data as you have and then query it whenever you need to. But in essence, the features are pretty much the same. We could have used a Parka server as well. We just happen to run this service as our product, so it's very convenient for us to use. So yeah, without further ado, what I started with is I just selected all CPU profiling data that is being collected by Parka agent. So just as a recap for those who may not know, Parka agent is kind of our eBPF based profiler that we deploy on every single node in our infrastructure. At Polar Signals, we happen to use 100% Kubernetes. So we just deploy it as daemon sets onto all of our Kubernetes clusters. And this Parka agent then automatically starts profiling absolutely everything in the infrastructure. And because the kubelets are also running in that infrastructure, it's actually very convenient for us to just look at one of our production Kubernetes clusters and start to look at what these kubelets are doing. So what I'm doing here is I'm pulling up the last 15 minutes of CPU time across all the kubelets in this cluster, and we can now start exploring this. So a couple of things to note right off the bat. What we can see here is this is some garbage collection stuff from the Go runtime. Kubernetes is 100% written in Go. So this is probably all pretty much not interesting because this is just runtime stuff happening. What do we have over here? Looks like this is this is a fun one. So we can see Prometheus collection is taking up almost 6% of CPU time. That's an interesting one. Definitely a case for maybe a future episode to see if there's some optimization potential in the Prometheus exposition format that would have similar kind of repercussions in terms of how widely this is used, right? If we can optimize that, we would probably have a huge effect on CPU cycles on the planet. Yeah, over here it's more metrics things. I mean, this is all prom HTTP, so even this is all prom Prometheus. So
just to make sure, I think it's readable. Just maybe like 1 or 2 times increase the font size. Yeah.
No problem. Is that better?
Yeah, I think that's better. Like on TVs or whatever.
Yeah, sounds good. So yeah, this is probably not super interesting for us to look at. I would say let's kind of look at the next biggest ones. All right, over here it's more metric stuff actually. So cAdvisor things, not directly the kubelet, but again could be an interesting one. Even if we don't end up writing code within the kubelet, we might end up writing code for cAdvisor. So we can have a look at this, collect containers info. Okay, so this happens whenever Prometheus does the scrape request, and we generate the actual metrics output. Something interesting about cAdvisor is that it integrates actually into various monitoring systems. And so something that we actually did with the Kube State Metrics project quite a while ago was we kind of ripped out all the actual Prometheus client library, because we can do much more optimized, much more opinionated things in a lot of these settings. However, because cAdvisor integrates into all these various monitoring systems, I'm not sure how viable that actually is. I think that would require probably some more research. We can maybe look at this. We're still at roughly 2% in CPU time. Update spec, get info. Looks like this is kind of obtaining information about containers. Internal spec. Yeah, I don't know how interesting any of this is. It just looks like I don't see anything really obvious. Of course, what we can always do is do a couple of searches of our magic things that we know how to optimize. For those of you who've maybe been watching a couple of episodes of Let's Profile already, one thing that we tend to see a lot over time, and it looks like this the Kubel is actually very good at this. Binary read does a bunch of unnecessary allocations. We could, whoops, what's going on here? Let's reload that. We could also search for runtime new object. This shows us, oh, that's also not present. Interesting. That means that in terms of allocations, there's probably not a whole lot that we're going to be able to save. I don't know what's going on here. We should create a bug report for that. Removing the filter seems to have a bug right now.
It's interestingly enough, like in chat, there was a rather huge back and forth between kind of like the API server, focusing on the API server. And Thomas pointed out that like when starting a Minikube on his cluster, like the fan starts and then it just like even in idle takes too much CPU overall. So maybe that's also like a nice baseline to even like see if like the performance can be improved for idle clusters even. Because yeah, I think there's definitely too much going on there. And then Mahaf was pointing out that, and sorry if I butcher your name, but like using just PGO to improve the Kubernetes binaries. So like the profile guide optimizations, basically telling the compiler from profiles what we want to aim for, what can be optimized up front. And he saw a 5% improvement for some scaling tests. So I think that's also a really, really cool idea, like one day to compile the binaries with PGO enabled and get like super, super big profiles for the individual binaries, and then throw them at the Kubernetes binaries.
Agreed.
But yeah, I think let's try it with the kubelet. That's why I wasn't like stopping you or anything.
Yeah.
But I think like the API server has a lot of potential as well.
Yeah, I mean, so far we haven't.
You already said.
we haven't really found anything interesting. So it's entirely possible that maybe we'll end up doing that.
Yep.
Okay, so let's see. This was about 16% of CPU time, so still pretty large chunk. So get mounted volumes for pod looks like there's something about reconciling kind of the desired state of the world with the real state of the world is, I guess, what I'm understanding here. We're still got like 8% here. That's still pretty good.
Just from the function names, you could guess this was a Kubernetes thing with like reconcile desired and real world and stuff.
Yeah,
funny.
yeah, definitely prevalent patterns. Yeah. Looks like here we're kind of doing this is just kind of waiting for backoffs. We're reconcile unmount volumes. Okay, this is starting to kind of look pretty interesting. We still got like 3 to 4% over here. And pretty much all this does is it appears it's iterating over maps. What's this? Get all mounted volumes from the actual state of the world. I like that. I like that struct name. Actual state of the world.
Almost like an Easter egg we found there.
Yeah.
Not sure how often that surfaces in other people's code, or like whenever they look at Kubernetes, like probably somewhere deep down.
Yeah. Yeah, we've got we're still at 2% over here, so this is pretty significant. This like thing, this one place in Kubernetes where we just keep iterating over some I don't know. It doesn't even seem like a very large map, but I'm guessing we're doing it really a lot. But I don't know exactly what this is. So it's something about volumes and pods. I think this might be worth kind of having a closer look at if there's something to be done here. So this tells us it's in package, kubelet, volume manager, cache, actual state of the world. Is that right?
Even the file name.
Yeah. And this thing is the volume manager reconciler. All right. Whoops. I was already starting to have a look at some things, but I did kind of just like in the this is
that's way too small. I would have told you if it was readable on stream, but it's like, again, on a TV it's probably hard to read or something.
Yeah.
But yeah, that's perfect.
So yeah, I already just like in the other streams, I already pulled down the Kubernetes repository because this is a massive repository. So I didn't want us to spend 10 minutes pulling a repo. So what was that? Whoops. What was that? Path. Actual state of the world.
Nice. I never tried that, but yeah, it should work. Just copy pasting the path to the file.
Yeah.
Opening it.
Yeah, absolutely. So let's see. The function that we kept calling here is get all mounted volumes. Okay, this is some interface, I guess. Okay, the actual state of the world interface. Okay, and then there's a concrete implementation.
Actual world interface. How can, if it's the actual world, how can it be an interface? It needs to be an implementation. Otherwise, it's just an interface of the actual world, right?
Yeah.
Getting philosophical.
Let's see. So what is this doing? We allocate. Okay, this might cost us something already. What is mounted volume? Just checking here real quick. This is an actual struct, and operations executor is mounted volume. This is also an embedded struct. So the reason why I'm looking at this is to kind of figure out are we allocating pointers here, or are we allocating direct size of a struct, right? So it looks like we're allocating value structs, so that's good. Pointers are always more expensive. Not necessarily actually, but like with the value struct, it's all laid out continuously within memory, whereas accesses with pointers, maybe into random memory, and sometimes it's better when there's contiguous memory being accessed. Let's see. We have the ASW, the actual state of the world, attached volumes. So this is, what is this? This is a map. Okay. So we've potentially found our first kind of offender of a map, because let's kind of recap where we came from. The profiling data told us that
let's look at the profile. Do you still have it open?
Yeah, the profiling data told us over here that like map iterations was one of the biggest users of CPU time over here. So even the initialization. So this makes me think that this probably happens a lot. But it could also be because we have two for loops nested within each other here. It may be the initialization, may be the second one, right? Actually, now, do you remember we've been talking about having like IDE plugins or something to show profiling data within the editor? That would be super useful here right now.
That would be huge, yeah. Just like knowing, oh, this is the line, not this other one.
Yeah, exactly.
Can we have that yet?
So we have the raw data, but we haven't written a plugin for something like that yet. But yeah, it would be pretty cool.
I'm also curious, like can you quickly go to the map that you just opened, and there was like the key was another struct, or it was like a type alias of some sorts, like the unique volume name. Like I just want to know what's underneath that one. Is it just a string? Oh, okay. Yeah, but just making sure. Okay.
Yeah. But what's funny is, and like it's interesting because we're doing these like map iterations, right? But we're never accessing the key. Like seems wasteful, right? Like map iterations are definitely more expensive than iterating over a slice, for example. So this could be,
I guess it's just for uniqueness.
Maybe it's
somewhere it needs to be checked then, right?
So maybe we can kind of make a mental note here. Attached volumes. We should probably have a look at where else this thing is used and how it's populated, so that we can figure out if maybe there's a way that we can do this for loop over a regular slice without doing map iterations, right? Like just a regular slice. And then within a volume object, mounted pods. Okay, so if I'm understanding this right, maybe we can also have some more read of some code comments. But if I'm understanding this right, this entire component is that we have a list of volumes, and we're trying to figure out which pods potentially, or I guess if we're the actual state of the world, which pods should, no, it's not the desired state, it's the actual state. It's the, which pods have these volumes mounted. I think that's...
Yeah, I think Yeah, exactly.
That's what
That's the
this
way I
is.
read the code as well. Yeah.
But there was some, so get all mounted volumes returns list of all possibly mounted volumes, including those that are in volume mounted state and volume mount uncertain state.
It's like that meme where developers just go ahead and read all of the source code, but like
Yeah.
ignore like the 10 pages long README which explains everything in detail and like perfectly written up. But
Yeah.
no, I'd rather read the source. we just bin these people.
Yeah. So actual state of the world defines a set of thread-safe operations for the kubelet volume manager's actual state of the world cache. Okay, so this is still a cache. I mean, I guess that's always going to be the case, right? Like the true values is whatever is actually mounted, right? This cache contains volumes, 2 pods. Yeah, that kind of reconfirms what we just said. For example, a set of all volumes attached to this node and the pods that the manager believes have successfully mounted the volume. Note this is distinct from the actual state of world implemented by the attach detach controller. They both keep track of different objects. This contains kubelet volume manager specific state. Okay. I'm not sure what that means, but I hope that, or the way I understand is that we can probably treat all of this to be kind of self-contained within this, which I'll assume for now is a good thing.
Yeah, there are some comments again on exactly that. So Sumer says, I wonder how much how many times the check succeeds. So probably how often like the condition within both nested for loops even gets true.
Yeah.
So we're probably doing lots and lots of repetitive work that kind of very few times yields results. And then Vadim says, by the way, hi, Vadim. Perhaps along with the attached volumes in AWS, and not AWS, like the actual state of the world, ASW, I guess.
Yeah.
That's probably what you mean. We could store the mounted parts too, so that we would iterate directly over the mounted parts instead of the nested loop. So kind of like getting away with one indirection. Yeah.
Yeah, that could be interesting.
Micah says code comments are like IKEA instruction manuals. You read them when something cannot be assembled. I think that's very true.
Very accurate. All right, so I think the only way forward for us here to like figure out if there's something useful for us to do is to figure out and kind of reconstruct these ASWs from some, maybe we can, figure out how this is populated, so that we can build a benchmark, right? Like what we always want to do is we want to build a micro benchmark that we can kind of reproduce something at least somewhat realistic so that we can iterate faster on making improvements. So I would suggest, let's see, where is this thing set? Attached volumes. All of these seem to be doing pretty much the same thing. And note, every single one of these for loops ignores the key. Like I'm looking more closely right now to make sure that I'm not missing one, but even this reading thing completely ignores oops. Yeah. Okay, so here it's different. Here we actually use a direct access. But maybe the trade-off is wrong here, right? So we can check pod removed from volume and have a look if we can find this in our profiling data. And if not, then maybe we can kind of, yeah, so that's good. That's good news. It doesn't show up in our profiling data, so that means that this is definitely, at least right now, a very cheap function. So maybe we can choose a different trade-off.
One of the few times that having no samples in your profile is actually a good thing. That doesn't happen too often.
Agreed. Aha, okay, so here something happens about deleting a volume. So this may be something that we need to keep in mind when we do this. So we'll need to be able to delete volumes and have some sort of fast access as well. Let's see. There's more deletions here. More direct accesses.
Yeah, Thomas had like a good point in chat. He said that you said it's a relatively cheap function, in quotes, cheap. Do you mean it's not called that often? Maybe it's cold because it is not a hotspot. I guess that's true, yeah. Like we're doing still like sample profiling, so we only see like, I think the agent does like 19 hertz, so like looks 19 times a second for stack traces. So yeah, we could definitely, if that's like, because it is like a direct access to the map, we could definitely just not see that. Whereas like the other way around, when iterating over the maps, is like way more expensive, obviously. Yeah, that's a really good point.
I think I don't understand the kind of breadth of this data very well, right? Like, do we have like the way I imagine this? It's the number of volumes that this node knows, right? Like even at, I don't know, what's the default pod limit? I think it's like 250 pods or something like that, or 120. Let's say 120, right? It doesn't even.
Yeah, I remember 120, but that's like from 4 years ago.
And let's say let's choose something relatively generous, I would say, right? Like let's say 10 volumes per pod. That seems like a lot, right? Like on average. Then we have 1,200 volumes on a node, like iterating over a slice of like 1,200 items is wildly cheap. I feel like there's something that we can do.
Yeah, like on a similar note, Timur in chat also had like the question, like, do we know how many attached volume like objects in that map are, and then like how many like elements do we have in the mounted pod? So basically the same question. I think like what we're kind of like seeing from the profile is that like probably the writing and deleting part of these maps is like done so few times, I would guess, just by it not even showing up at all in the profiles, that like the read path, and I guess that makes sense given we are dealing with Kubernetes where like constantly everything is read and like compared. Like the read path is just the hotspot overall. So yeah, I guess that's what you're getting at as well, right? Like the trade-offs are kind of interesting here, kind of like the other way around than at like a read heavy system should probably use.
Yeah, I agree. So I think what we should what we should try to see is how is this data produced, so that we can kind of recreate a benchmark like we said, and then we can see what we can do. I think I saw just now this attached volumes, volume name equals, what is this function? Add volume. Okay, that sounds pretty good.
Do we see that in the profiles, add volume? Like the more like high level function call? Is that ever showing up?
What was it? Add volume.
Add volume, yeah.
Yeah, I would have been surprised if this was different, right? If we changing the volumes happens very infrequently in Kubernetes, right? Like even if you schedule new pods, like this doesn't happen, probably doesn't even happen more than every couple of seconds. So this should be comparatively, this should happen extremely rarely.
Yeah.
Okay, there's another one here where we're writing attached volume mark for in use expansion error. Get device mount state. Here's another one. Update reconstructed device path. But actually we need to be careful here for a second, because what this is doing is it's retrieving the volume object. It's setting something on it, and then writing it back to it. And this is because all of these are value structs, and that's how they're updating it essentially. So this is like what we mentioned earlier at the very start when we started exploring this. We said that there are no pointers involved here, right? So this is how they're fixing that they can still update things within this map. So let's double check that the other times where we saw things being written. Okay, here it's exactly the same thing, right? We're actually just updating things. What I want to find is where do we kind of originally write this data, right? So that we can see what is the original source of this, so that we can reproduce it in a benchmark.
I had the idea, like, or impression that it was in the add volume. Wasn't it?
Yeah, it could be.
Okay, just making sure.
I was just trying to see. So here we're trying to read it, and if not, yeah. So here we're creating an attached volume struct and then writing it. Yeah, I think you're right. Let's just, for good measure, make sure that this doesn't happen anywhere else, right? Attached volume. Yeah, okay. And just because it could be package-wide. Sorry, what was this name again? Attached volume. What is it? Minus R? Yeah. Okay. So it's truly the only time where this struct is created. So where does all of this data come from now? So volume name came from here. Okay, so that's passed down into the add volume function. So is the unique so is the volume spec, as well as the device path. Oops, I went too far here. And then we use that to find, what is this? Volume plugin manager, find attachable plugin by spec. I guess this is if the volume is like a, whatever, to find whatever plugin is being used for this. So like if it's an AWS volume, if it's a GCP volume, if it's an NFS volume, whatever, right? I'm guessing that's what's happening in here. And then we take all of this and we check one more time that this thing doesn't already exist. What happened up here again? Get unique volume name from spec. Okay. All right. So in the way that this looks to me is that we essentially read whatever all the mounted volumes are, put them into this attached volume struct, and then how do we find out whether pods are attached to this? We had that. What was the original function again that we started exploring?
Yes.
What's going on here? Get all mounted volumes.
Yeah. Yes, that's the one. That looks like it.
Okay, so the mounted pod. Where is this written to? Sync reconstructed volume. Unique volume name. Unique
that
pod
seems
name.
Oh no, it's not for loops, it's ifs. Very nested. Okay. But that only... Oh yeah, this one writes it, right? Yeah.
Okay, so this is yet another map within this. I do feel like this is going to be a tough one to optimize. I'm not sure we're going to be able to finish this today, but I think we can try, and we can finish it up in a follow-up stream. Or maybe I'm wrong and we'll be quicker than we think.
I'm also kind of thinking about the ergonomics of maintaining this going forward, right? I think there are ways to make it more performant, but then again, it might add some complexity. So, yeah.
Yeah, no, I think this is definitely a case where we would make it a little bit more complicated if we optimize it. So the things that we need to think about here is we need to be able to delete quickly, and so deleting something somewhere from within a list that may be difficult, right? If we've already appended more things to the list, we would need to like compact it or something like that, which is kind of something that sort of happens automatically with the map. We could definitely use, a little bit more sophisticated data structures. Maybe we could use like a doubly linked list, where we But then we still don't have kind of a consecutive piece of memory. Difficult.
Yeah, like a tree structure maybe, but that's like optimizing for deletions, not necessarily inserts. Yeah. But it doesn't need to be ordered,
actually,
right?
a tree, like actually like a TRIE, like like a prefix tree. This could be interesting, because we would have the volume, and then the next thing would be the pods within that volume, right? And there are actually pretty nice tree implementations in Go, where we can do things like prefix lookups. Also, if you don't know Dalton, you should go ahead and follow him right away. He's awesome. I have actually used this package once or twice before, and it's definitely really, really good. So yeah, this would allow us to kind of store things with prefixes, and be able to do lookups really quickly. I think lookups are also yeah, get performance allocate 0 bytes, so this is also super fast. It could be something that we could do. What would that look like? If we go back to this.
Just before we, yeah, like, can we look at like what walking or like iterating? I guess we don't necessarily need to iterate anymore, right? Like that's the whole point, yeah. Because like I was just looking at the walk function there, but I guess it's more of a like we always get things from the tree.
I mean, so if we look at we could even have like let's just like sketch this out for a second. You know, just like notes. Like we could have sort of like let's look at this as, you know, like a file system structure, right? Like we have the volume, and maybe this could actually be like the volume struct, or what did we call it again? My memory today is not holding up.
The unique volume name, or which one? The other one?
The struct name of this.
Yeah, these are too long to remember. Honestly.
It's an attached volume. So. Oops. I already have it open.
Thomas says in chat, like, I'm new to Go, but I heard that moving memory is fast, so maybe deleting from a slice is not that expensive.
Yeah, the deleting from a slice is actually super fast, or at least, you know, nulling it. The problem is if we have a slice and we've appended multiple times to it, and we now realize we need to delete the item at this you know, index number 2 or whatever, that memory that we have is still allocated, and we don't necessarily have a way to figure out, okay, this is where we should insert the next item. We could use more complex data structures that can do some of these things. but it's all trade-offs, right? But deleting or nulling is definitely super fast. Absolutely.
Mm-hmm.
It was more a trade-off of data management more than anything else. But in my mental model, we could have something like this. That then, I think that was the struct name, the mounted pod struct name. If we
So kind of nesting them in the tree.
Yeah, exactly. Because if we go back and look at this is not a lot of space. Get all, like all of these for loops, right? What they were doing is that they're ultimately trying to iterate over everything that's a mounted pod.
Mm-hmm.
Actually, maybe we need two trees then.
Yeah, that was my fear as well.
But
so the only improvement would be having maybe faster, but we don't have faster access if we have two trees and we need to compare things again. Then we end up in the same situation, walking everything, right? Like you can see down in the bottom half.
Sorry, where?
Like, I mean, like in the code, like we have these two nested for loops, and if we have two trees, you mean like the
no,
one
in
tree?
this case, we would only iterate over this tree.
Right, I see. The tree is still nested.
Because that's the only thing that we care about here.
I read the thing on top incorrectly. I thought we'd have like a tree with the volumes and one with the pods, but then we'd end up in the same situation. But this way, if we still nest it, then it's fine. Yes.
Yeah. All right. I gotta run to the bathroom, but maybe we can think about this some more, and I'll be back in 5 minutes.
Yep. Maybe you can. Sorry, before you. Okay, he's gone. I was just asking if maybe we can like read through 3 data structures on Wikipedia that he had opened. Bathroom where the best ideas come to life. Definitely the shower for me. Oh gosh, the amount of times I've been in the shower and all of a sudden ideas start popping up, right? For the ones that are more visual like me, could you provide some visual example? Yeah, that's why I was hoping for us to look at the Wikipedia page while he's gone, but we don't have like a Team Viewer, VNC or like anything session, so I can't do anything with the screen you're seeing for now. But I guess like let me try. This will be interesting. I can just open the Wikipedia thing on my phone and hold that into the camera, maybe. Is that visible? And then essentially what we want to do is we want to have the tree in a way. Am I like blurring my I'm blurring, so that's why like let me disable the blur effect on the video call. But like the tree has the all of the volume names such that you can like walk the tree and you get like down to like number 9 or something, where you then know okay, so if we have that prefix available, it means the volume exists, right? And then if we put the volume and then the pod names below these, we know, oh, okay, so the volume and then pod name, like the combination actually exists. So we can kind of like walk all the way down to the volume and pod combination. I was just holding the tree Wikipedia visualization on the phone because I can't do anything with your screen.
Sorry about that.
Oh, good. I was just hoping maybe you could like open the Wikipedia article, but then you were gone already. I think Nicola says it might have worked. But yeah, just like how does that visually look, right?
Yeah. So
if it's a tree or a linked list. Okay, yeah, no, we're definitely talking about like a prefixed tree.
Yes, exactly. So on every edge, we say what is the prefix, and then, or the like continued prefix, right? This can be arbitrarily deep. And yeah, basically that would mean that all the pods that mount the same volume would have the volume prefix, right? The same volume prefix. And that should make it fairly quick to iterate over that without needing to, hopefully doing anything more complicated than maps already do. Maybe this is kind of a lost cause. I have no idea. But I think it's maybe worth trying. So I would suggest, what if we do what we said about the micro benchmark, where we build a kind of hypothetical setup. We just do, like we said, 100 volumes. 1,200 volumes that are mounted by 120 pods, and then we see what the benchmarking data looks like, and then we could replace it with a tree and figure out if this even makes any sense, right? Maybe we'll see some very similar performance characteristics, and then it maybe doesn't make any sense at all, right?
Yeah, I think that's definitely worth trying. And even if it doesn't like yield anything, we learned something about tree and like a tree implementation of Go.
Yeah.
So,
I was just thinking, actually, also we've had quite the strain of luck with finding really good performance optimizations so far in the streams. I think this is also, very much reality, that sometimes if you try to improve something, you're not necessarily successful, right? It's all just reality.
I think like oftentimes you need to think in the bigger picture and kind of like re-architect the way like the application is even like constructed in the first place, and then how you like access all the objects, etc. And then you can kind of start seeing real benefits and gains. I think it's often a lot more work than just throwing a profiler at it and hoping like this is the one thing I can just easily like get 20% off.
Yeah, but at the same time,
I wish it was that.
We've seen with Cilium, right? Like we were able to shave off 4% in CPU time just by optimizing one function. So oftentimes it is that there is lots of low hanging fruit. It turns out Kubernetes is well optimized by lots of engineers already. All right, let's try this then. What is it that we're doing here again? We need some data in attached volumes, and we need some data in mounted pods. It's hard to say how often we hit this particular segment, right? But maybe what we can do is we can see if we ever find get mounted volume in our profiling data. That probably tells us whether Okay, so we can assume the worst case, I guess. Like, what if every single volume is mounted for every single pod, right? Then
Yeah.
this gives us kind of the worst case. Maybe that's not representative. I'm not 100% sure, but we can have a quick look at how much get mounted volume occurs in our data.
Yeah, I guess that's like the original question by Sumer as well, where like how often is it even true? Like how often do we actually evaluate to true, have a result?
Yeah.
Do you think that the tree will also somehow hold mount state of the pod? I see lots of volume mount state for pod access during iterations. Interesting. Yeah, hard to tell right now.
Yeah, I mean, we would need to access the mounted pods exactly.
Mm-hmm.
Actually, it looks like we would need let's write the benchmark, and then we can see how we can restructure the data. All right.
Yep.
Um,
And like pointed out earlier as well, like in line 973, like we kind of have the capacity already pre-allocated. So at least we know like upfront what the amount of attached volumes is going to be. I mean, it's still like it still depends on the actual state of the world, and it could be anything, right?
yeah,
So
absolutely. But something that's interesting here is that we're only pre-allocating the number of attached volumes, right? Whereas potentially we are actually appending whatever the total volume, the total number of mounted pods within all of those volumes are, right? So it is possible that this ends up, or here that we end up spending some CPU time in appending this. It does seem like we haven't seen this. We haven't seen any like grow slice or something in the profiling data, so it seems like it's not the allocations that are taking the time here.
usually it's enough, probably. Yeah.
Yeah. Yeah. Okay. Let's get to it. Oops. We still have our notes. I guess we don't need these notes. Actual state of the world. Let's see, maybe we have some like test data that we could use. Pod. Get unique volume name per spec. Volume get test kubelet volume plugin manager. State of the world. I'm guessing this is some sort of fake. Yeah, fake kubelet volume host. But I think we can even do something more minimal just to start with, just to kind of see if there's anything to our theory.
Yep.
Let's go.
Just the bare minimum of getting something in a benchmark. Yeah.
I keep forgetting today the name of this function. And we said we want we want 1,200 volumes. And with 120 do this volume. And we want to say that on average 10 pods. So maybe we can make it we want to keep it like our at our 120 pods, right?
Yeah, I was just like laughing or kind of like being in awe because Sumer posted in chat that he found a benchmark where it suggests that like iterating over a slice is roughly 20 times better than iterating over a map, possibly due to the cache locality. So yeah, I think that's what we said earlier already as well, right? So yep.
Yeah, exactly. So hopefully we can reap some of those benefits with a tree as well. So how do we identify like one of our, I guess what we can do is, I don't know, we don't want the same pod twice for the same volume.
You can use the AV volume name in like 1324 is a command.
Sorry, what?
Trying to understand it myself. I don't know what to...
This is something else.
Yeah, okay, probably.
What I forget what this is. It
As
was
the probably it was a comment on reusing the volume name from AV. Yeah, AV volume name, like we are like using the fumt printf again in 1324.
I see.
Like accessing the map there. We can just use av.volume name instead because we already have the key.
Yeah, definitely.
Nice.
Yeah, nice catch.
Very good.
I feel like there's something that we can do here. We iterate over all of them, and if like J? Does this make any sense?
I think it does. I think the way I thought about this is the other way around. J mod I. I guess doesn't make a difference.
No, I don't think this makes sense. But what we want to do is we want to select pods so that they
spread evenly, right?
Spread evenly across the volumes, yes.
Get the next one in the next iteration, kind of.
Boy, it's so hard.
Math
doesn't help to have to think on a stream. So we want volumes to be unique for a pod, actually.
That's what we want. I thought like we were kind of like mounting a volume up to 10 times into a pod. Because we have like 1,200, like we have 10 times more volumes than pods, right?
Exactly. We want to mount 10 pods in 10 volumes into each pod, and we want there to be a one-to-one relationship to that, but like for that. What if we did this a little different and said that no. We actually make I the pod counter.
Yeah, the other way around, and then have 10 inside of that, right?
Yes, exactly, and then do 10.
I think that's an easier way of thinking about this.
And that way we're also saying the pod is actually pod name like so. And then volume is I times 10 plus j. Yeah. Like so. And this. And we needed to still set the, what was it, mounted pod? Is that right? What is it saying? What's a comma? Is there anything else in mounted pod that we need? And what is used in get mounted volume? Get mounted volume constructs and returns a mounted volume object from the given mounted pod and attached volume objects. And immediately returns. Okay, so so we can just do that, and then we said we need to have a pod object volume mount state for pod. We'll just make all of them mounted. And this is in the pod object, so it's right here. Volume mount state for pod. Yep. And it's operation executor dot volume mounted. Okay. So we've got attached volumes. Okay. I guess now it's time to, we want to reset the timer and then
Yeah.
run this.
I'm curious if that works.
It should work. Why wouldn't it work?
I don't know. Something deep down in all of these tracks we're missing. I don't know.
Possible. Do our good old trick of ignoring all other tests, and we run our benchmark. Whoops. Yeah, looks like you were right.
You've
437.
too many nested data structures, like structs basically.
Yeah.
So I'm always.
Sorry, I closed my editor. Now go please is reinitializing, which with the Kubernetes code base, I'm impressed how quickly it fully initializes for code search to work.
Like early, I could already tell it was doing that. Like for 1 second, it had a hiccup on stream. Now it worked fine though. I didn't see anything.
So get mounted volume. Whoops. That is 11797. Okay, yeah, this exactly this one. Because what it's doing is volume spec.name.
Mm-hmm.
Do we do any other accesses like that? No. So it means that we need to set volume spec and a name within that volume spec.
I guess we can just call it data or something, like we often do in Kubernetes.
What do you mean, data?
No, just data.
Aha, I was going to call it exactly the same as this volume name.
Oh yeah, go for it. Ah, but that's the... Yeah, okay, never mind. Whatever. It really doesn't matter.
Well, I think for this test, it doesn't matter, yeah. For this benchmark. Volume spec is undefined. I think does it need to go in here?
It's...
No.
No.
Mounted pod. Volume spec. What's incorrect about this? I don't see it. Oh, you know what?
We are like somewhere like nested incorrectly,
yeah,
right?
This is incorrectly nested, yeah. Yeah, because this is the map key and this is the actual mounted pod.
Yeah.
Yeah.
People in chat know should go line up. Good.
All right, so we've got it.
Please do let us know. Even with 2 people on stream, it's always nice. Okay. We have a benchmark.
Yeah. So, yeah, and this looks pretty much exactly the same as what we saw on the production data, right?
Yep.
So
yeah, like super close.
So I think, and maybe we've already been at it for almost an hour and a half. Maybe all we do today is kind of replace this like not even write any production code here, but we just kind of replace this with our tree data structure. And see if this even makes sense to pursue further, right? Like we're not changing this thing at all, because the compiler would go haywire because everything else is messed up. All we would want to know is we want to have all of the
Interesting. Yeah, like a good point in chat, like the map iterator init, I guess, takes too much time to know, which was that the case in the production data we've seen earlier. So basically comparing what we have in this benchmark with like what we had in the profile before.
So probably the data that we produce is not actually representative of what we're seeing in production, which is probably true, right? So this says this now tells us line number 815 is where it's at. 815, what? Sorry, that's the map code. All right, I think we might need to unpack some features that we don't have in Polar Signals pprof me yet. And we'll take out the pprof toolchain for that. And we'll pull out the, whoops, what am I doing here? Yeah. And we'll use source, and it's the get all, what is it called again? My brain is...
Get all, get, it says in the benchmark name on top.
Yeah.
Get all volumes, get all mounted volumes. Yeah.
So it looks like we have, I know this is our data, right? So yeah, it's that we probably have too many
too many mounted parts.
Yeah,
I guess. Yeah, like the volume seems fair, but the mounted parts is like a lot more now.
So that would mean that we have maybe then more like, let's say 2 volumes. It's still quite a bit higher. Why would that be? Are maybe multiple...
I don't know this about the like implementation details. Maybe like Go reuses map iterators in the runtime, and I mean we had like in the kubelet itself probably lots of map iterations before, so could be that like initializing them isn't the problem anymore. I don't know. We would need to read the runtime code now.
You know what? Could also be actually in Polar Signals, this may be inline. So this may be inlined. And we would only see this this frame in Polar Signals, which is the thing that we're working on. There's some difficulties around Go inlining decisions, and we don't fully support every single thing that can happen. So it may actually be that that some of these map iter next that technically are under map iter init end up over here. Hard to say. Definitely something that we need to still improve. I think maybe we can still write a benchmark from here.
Definitely.
It looks a little bit closer to production now.
Yes, Suma says like in chat, like the map iters most of the time comes from the next calling. So yeah, exactly. Like there you can in the call graph see it also really well.
Yeah. And I wanted to.
In the map, since attached volume type is not a pointer, copying can also cause the slowdown.
Yeah, potentially. There are fairly large structs, right?
Mm-hmm.
So then oops, that was correct. And we'll use this free package. Oh, maybe it'll automatically do everything. It is a free, and we want, what does get all mounted volumes return again?
All right, Thomas and Zoomer need to leave. Yeah, no worries, but it was super nice of you being active in chat.
Yeah.
See you next time.
See you next time.
Oh, Kemal just showed up.
Hello.
Did you get the polar bear emoji? Does that exist? Is it a YouTube thing, or is it like an actual emoji? Maybe I forgot. Which would be ridiculous, right? If people don't know why we're posting polar bears at Polar Signals, we call ourselves polar bears. It's an actual emoji, Samara says. All right. I forgot, it seems. I need to use that emoji more often. The more you know.
Okay.
I'll make it an OKR for the second quarter this year. Use the polar bear emoji at least once a day.
So, like we said, I think we are going to need we'll have volumes. We can maybe start with a map, because we'll do direct accesses. Maybe this won't make any sense. I don't know yet. Maybe we'll make this a tree as well. I don't know, what was this? Yeah. And then an attach volume. Which actually would mean that we're keeping this exactly the same. And we would have a volume pod 3. that is a new path 3 dot new path 3. And we essentially take all of this. Don't have this if statement and don't have any of this. But we would that was incorrect. What is attached volume again? Not my day. Okay, it does have a dot volume name. And we do that, and then we go path, make a path out of it, and we also append pod object, which is a mounted pod, and it has a pod name. This is incorrect. Oh, it looks like we closed that a bit too eagerly. Over here. All right, and with put. I think we maybe haven't correctly installed this just yet. But we need a key and a value. So the value here would be the pod object. And so if we have the path tree and the volume that are in map. And for the record, maybe none of this volume map makes sense. It could be that this is also causing some of the slowdown, but we're still experimenting. So we want to walk, I guess, all of them, not just a specific path. Yeah. So we do p.walk, and it's a walk func that is so. Okay, looks like that's actually correct. And oops.
Looking at this code from the tree package, I wonder why Dalton wrote this package. Like, what for?
I'm
7 years ago?
I'm going to guess because there was something about routers. I'm gonna guess that this had something to do with like IP routing or something like that. I want to say last time I looked at this package, there are also some tests somewhere that do like IP matching or something like that.
Right. Yeah, that would be
if you wanna pull it up, I think
a perfect use case. Yeah.
Yeah. All right.
It's just what like Go packages that are like so small yet so complete, and it's just nice to see a small, well-defined library like this.
Definitely. I'm just trying here. I'm trying to be as close as possible to the rest of the other function. I guess this is correct, right? Why? Yeah, okay. I'm guessing I still have. What is this return value? Returns an error. The work is aborted. Bool. Ah, this is incorrect.
Hey, welcome, Anki. Yeah, we actually been streaming the last 3 or like 2 weeks. This is the 3rd time.
Yeah.
And we've been coding on live stream, yes. For what it's worth, there have been other live streams, like TGIK comes to mind, and like there are some coding live streams on Twitch happening as well. Yeah. But it definitely is rather a rarity.
Something we're not doing quite right here. If this is the closing one, that's not right.
Where is that even?
That seems correct. No, that does not. Oof. What is going on?
That's closing the function now. So there's like one too many, or one of the normal brackets too many of a closing bracket or something. Oh wait, the get mounted volume, like the 1359 has like 2 closing.
Okay, this looks better now. This is
I don't
correct.
know this. Yeah.
Okay, okay. I don't know. I can't see where there's a syntax error right now. Maybe we can
I think now.
Inconsistent vendoring. Oh, this is already explicitly. Huh. What did we do here then?
I think you just need to go mod vendor, because they actually put the vendor folder into the Git project, right? I don't think that happens a lot these days.
Yeah.
That's why I haven't run go mod vendor in. I used to run this all the time and like with go dep and stuff. But these days I never check in the vendor folder.
1351.
That's why. Yeah, I think the return needs to go one further down.
You know what? Here we don't have the map value. An attached volume. All right. There we go. But now it says undefined.
Well, that's weird. I guess the package needs to be imported.
Usually package imports work for me. So this is surprising. Cannot query module due to error. Did we? Oof.
Did you run the Go mod thing from the top of the project?
No, but you don't have to.
Oh, okay.
Let me check out all vendoring stuff. Just
Making sure.
because if I understood what it said earlier correctly, it was saying that we actually already have tree. Okay, cannot query module due to dash mod vendor. Go version in Go mod is at least 1.14 and vendor directory exists.
I've never seen this error message. It's crazy. Since I never use Go mod these days, vendor. So what? Cannot query module. So it can't like download the thing from the mod registry.
Can it not
It
download
needs to
this
be in
thing
the
maybe?
vendor folder, right?
Looks like Dalton. Oh, there's a Go mod and everything.
No, I think it says like it can't. It won't just like on the fly read this from the like online registry, if you will.
I see.
But it needs to be in the vendor folder. That's how I read this.
What I understand though is that this thing is already used. Oh no.
Like implicit.
No, it's not. Okay, that was incorrect then. So, but if we did now add it to the import, right? So if we now do go mod tidy.
Yeah. Go mod tidy, go mod vendor. Yeah, there it is. I always thought you need to run them from the root.
It looks like that worked now.
Okay, nice.
So 1 through 2 7. Declared and not used. Okay, so we want to pass that onwards. And undefined volume object 1360. Yeah, we still need to find the volume object. So we don't have it the other way around, right? Like mounted pod doesn't say what. Like containing special. Oh wait, what? Is there a one-to-one relationship to this? Outer volume spec name.
But you can have volumes, just like from my understanding of volumes in general in Kubernetes, like you can have volumes that are read-write multi, no?
Yeah.
So it shouldn't be a one-on-one.
But I think this is... Once again, we should read the code comment.
IKEA and stuff.
Spec is the volume spec containing the specification for this volume used to generate the volume plugin object and passed to plugin methods. In particular, the unmount method uses spec name as the volume spec name in the mount path var lib kubelet pod id volumes escaped qualified plugin name volume spec name. Okay.
If you scroll down a bit, people can read it, or up, yeah, down, so the text goes up. Because we are like hiding it.
Sorry about that. Yeah, thanks for calling.
Just the last.
Yeah.
Just the very last little bit. Yeah.
But it doesn't really matter. Yeah, we just need to take the path, and we do yeah, exactly that. And then we get the volume name with that, and the volume object. I think this is it now. We actually made a mistake earlier. We didn't save our benchmark results. So
I thought you copied the one. Damn it.
But it's okay. It's still in the history. We can scroll up and just checking if we have a result here. Yeah, we definitely do.
Maybe do that now and put it into a file.
Yeah, that's what I'm gonna do. I think I can already see that there is a pretty large improvement. Yeah. So we don't have enough significance.
Yeah.
Anyway.
But I mean,
I think this is pretty obvious. That there's not gonna be massive variation between this. So
I didn't know about the delta test none.
Yeah, you can basically say like ignore
statistics.
ignore all statistics. Just tell me what the real difference is between these two values. But yeah, interesting. Let's just have a quick look at this benchmarking data now. Where now we're spending data. So now we're primarily spending it in. Here we're seeing grow slice. That's interesting.
I guess because you're like appending, right, in the walk.
Yeah. But we are doing the same pre-allocation. But yeah, it looks like this is going to be faster. We would be able to cut down roughly, what did it say? Roughly 65%, 64%. So like 2/3. And what did we say originally was we've got about 2%. So we can cut down a good percentage point of CPU time from all kubelets. I would say that's not shabby.
It was definitely one of the harder ones to figure something out. So I'm even happy taking away 1% and calling that a success.
Yeah, agreed. But yeah, I think we've been at it for almost two hours at this point. I think we can still take this as a success. We found a possibility of how this could be optimized. It would definitely still take some time to pull this through.
Yeah.
But
like all the put and delete and so on and so forth statements, and right, like that's probably the biggest chunk of work that would need to be done.
Yeah, I think so. All right, cool.
Nice.
Maybe next time we'll find something that where we can deploy something actually.
Yeah, I was just gonna say, let's just like quickly pull up like an API server profile and see if there's like how just like to gauge how they look, and maybe we can already spot something for another time.
Yeah, we can do that.
Nicholas needs to leave, but thank you for hanging out.
Thanks for coming.
And he posted a polar bear. Perfect.
Oh, you know what? This is the GKE cluster.
Oh.
And they managed the control plane.
Right. Interesting.
That's why we're not going to see API servers.
I guess I have the same problem with the Scaleway Kubernetes cluster. Let me quickly see if I can like upload a pprof otherwise, but I'm afraid, yeah, same problem. Yeah, adapter alert manager, but I can't see. Maybe Kube API server. Nope.
So we were actually kind of lucky, and we by going after the kubelet right away, we kind of we even went after what we could, right? I didn't put that together before we started this, but yeah, I mean this was pretty cool. I do also think there's probably still more to explore here. There was kind of this entire other path of what was it, the populator? I feel like there was something about no, that's what we were looking at. Sorry about that. I feel like I saw something about the desired state of the world or something like that. Here it is. Maybe there's something down here still, but yeah, what do we have here? Again, map iterations. I know this is the actual state of the world. Aha. This is cool though. And actually, maybe we can pull up a different visualization here. Get mounted volumes. It's not exactly the same thing, but oh, what's happening here? Oops. Okay, looks like we've got a bug.
That never happened before.
But what I was trying to say is, oh, now it works. That was weird. We've got the get mounted volumes for pod. That seems to be the only one we see here. I know this is, I think, loaded on demand or something. Whoops, that was unintentional. Okay, it won't reopen that tab for some reason. Weird.
But what you are trying to get is like there are more functions calling the one we just optimized?
Yeah, or at least the general kind of area of what we were optimizing, right? Here. So it's not exactly the same function, but I think maybe it's actually a subset. Let's try this. So we've got this. What was the function called again? Get all mounted volumes. Get. Okay, so what if we changed this to this? Aha! So that's what I was trying to get to. So actually, because we're optimizing two very similar things, we would be optimizing away probably a good chunk of this one. And if I'm understanding this correctly, this actually iterates over a very specific pod, right? Like it passes down, we can have a look at this for a second. It probably passes down the specific pod name or something like that. And so the tree would actually be like TRIE would actually be really interesting here again, because we could use that prefix to iterate over everything with that prefix, right? Because the pod would be the prefix.
Yep.
Or no, actually that's wrong.
That's the pro. Like it's the volumes and then the pod, right?
Yes. It is. But nevertheless, even if we had to iterate over everything, that would still be faster, right? Just like in the other function that we have. Let's have a quick glimpse at this. Get mounted volumes. Yeah, so this worked pretty much exactly the same way today already. So, yeah. Wait, is it the same function after all? Get mounted volumes? No, get all mounted volumes. Okay.
Yeah. But the code looks so similar.
Yeah, it looks very, very similar.
If would be helpful now.
I think it's only the if statement that's different.
Right, yeah, it doesn't have like two
There's another
conditionals, right?
Yeah, exactly. There's another condition that is accepted for the other function, but ultimately that means in two functions we would be able to reduce 65% of CPU time. So at that point, let's see what that would mean.
Yeah, that's a feature we're currently building.
Yeah.
There's a pending PR for Parker to get the relative and absolute percentage.
Yeah.
Now this it's like
super nice. So here it's 2% roughly, right?
Yes.
And over here it's another 2%. So we would be able to cut down, a good 2% in CPU time from the kubelet overall. That's not bad at all. All right.
Nice.
I guess we've
just using a different data structure.
Yeah. Yeah.
Yeah, I guess we would need to see if that would make sense to like put another data structure into the kubelet if the maintainers are interested. Could reach out, open an issue or something.
Yeah. Yeah, I think that probably makes sense in this case to first start a conversation around how to improve this. Maybe maintainers already have an idea of something different that could be done, or maybe something's being restructured anyway. With a project as big as the Kubernetes project, that's definitely always the better thing to do to first open an issue. But yeah.
Nice. Yeah, but I think like the Kubernetes project in general, like maybe we can get like also done by Dalton, not a Go package, but the Kubernetes distribution he has, like Typhoon. Maybe we can start a cluster and like also look at etcd Although to be fair, XCT is probably one of the best ones. I would hope. But there's so much we can probably then see in a cluster that's under our full control, and then also API server, like definitely interesting. And just like while doing the stream, I think also really interesting for a future exploration in a live stream would be just deploy Kubernetes and then just see what we can find. Just like vanilla Kubernetes, if you will. Just take the manifest and see what's up. Probably
Great.
Node exporter, I can imagine, or some places like that.
Yeah, node exporter. I think that's a really cool future one to explore, because again, just like with the kubelet, it runs on probably potentially millions of machines out there, right? So if we can just cut down a few CPU cycles of that, that would be huge. So yeah, I think that's a really cool idea. I think node exporter. I mean, I know we'll leave it for a future stream.
We'll see.
Yeah. All right.
But there's more to explore.
Definitely.
More to profile. So let's profile.
Let's profile. All right. I love that ending.
So cheesy.
All right, cool. I had a lot of fun. Thanks to everyone for stopping by in chat.
Yeah, great suggestion this time around in chat. Like definitely very lively.
Yeah.
Keep it up.
You know, hopefully see everyone next time. And yeah.
Have a wonderful weekend.
Yeah. Have a great weekend and happy profiling.
Bye bye everybody.
See ya.